examine the blocks in the liquid and based on the position determine which block have an approximate density of 0.3 grams per milliliter, 0.9 grams per milliliter, or 2.0 grams per milliliter. Based on these observations, it looks like to be water, but the one that sinks the most should have the largest density. So 2.0 grams per milliliter looks like would be block B. So I would write 2.0 grams per milliliter here. The one that's floating the most should have the least density. So 0.3 grams per milliliter would be block A, 0.3 grams per milliliter. And then block C would be 2.0. Block C would be, it's floating sort of in the middle or barely floating, and water has a density of 1. So block C would be 0.9 grams per milliliter, so I would write 0.9 grams per milliliter. Then number 2 is saying, for each box, examine the blocks attached to the balance, and then based on their position and size, determine which one is more dense. So density is really how heavy something is for its size. And in the first object, we can see that the darker blue block is more dense because it's smaller and it's heavier. So for its size, it's much heavier than the other block, which is big and not as heavy. So this block would be, so I would explain that. This block is the most dense because it's very small and it has a higher mass. On the other hand, we have two blocks that have the same size or same volume, and this one is heavier. So since the size is really not a major factor here, we just go by the mass, and a higher mass should mean a higher density. So in this case, this block would have a higher density. However, here we cannot really determine it because density is really saying how heavy something is for its size or its mass compared to its volume or the proportion of mass over volume. This block is heavier, but it's also bigger, and this block is smaller, but it's also not as heavy. So in this case, we don't have enough information to determine which block would be more dense because no block really would give us a clear proportion of mass over volume in this case.